Military aviation and stealth plane technologies. We made a project in an active and developing field. By the way, this is a t-shirt of the science fair. I was nominated as a finalist to participate in IntelliSEF, and this is my finalist medal. In this project, we aim to produce composite blocks with using iron oxide and titanium oxide and characterizing the blocks, radar absorbing properties in 812 GHz band, which is the most common band in radar applications. Radar waves that we're talking about are part of microwaves and have large wavelengths. The 812 GHz band is also known as the X band. In today's military industry, radar absorbing materials or RAMs has a big role. It is widely used on stealth aircrafts which are invisible on radar. RAMs are the most effective stealth plane method. The other methods, such as shaping, is not so effective because of aerodynamic designs of a plane. So what are the general properties of RAMs? The main goal is to reduce the reflection from material. In the majority of previous research, ferromagnetic materials were used. In our research, we compare ferromagnetic and diamagnetic materials and examine the benefits of diamagnetic materials. We choose our insulator materials due to their dielectric properties. In the production process, we use epoxy resin as a molding material since it is cheap, easily obtainable and compatible with our radar absorbing particles, iron oxide and titanium oxide. First, 0.1 gram iron oxide and titanium oxide was mixed with 10 ml epoxy resin and 5 ml hardener. The solutions were molded in a 0.7 cm thick circular mold. Then 0.05 gram of titanium oxide was mixed with 10 ml epoxy resin and 5 ml hardener. Blocks with same thickness, 0.7 cm, were obtained. These are the successful samples that we produced. The measurements, we used vectoral network analyzer to measure the reflection loss properties of iron oxide and titanium oxide blocks. Short circuit port of VNA was used in this process. The measurements were named S11. S11 is the reflection of waves that were sent from port 1 of the device and retrieved by the port 1. The rates were measured in decibels. The measurements were graphed with CalliDeGraph program. The graphs are also available in the research report. This graph shows the reflection loss values for titanium oxide and iron oxide blocks with same concentration. Iron oxide block has a maximum rate at 8.9 GHz, the red one, and titanium oxide has a maximum at 9.2 GHz. As it's seen, ferromagnetic iron oxide has a higher reflection loss value than titanium oxide block with same concentration. This graphs show the reflection loss value for blocks with different concentration of titanium oxide. The block with lower concentration, the red line, has a higher absorption rate than the one with higher concentration since titanium oxide is a diamagnetic particle. The reflection loss value increases as the concentration decreases until the optimum value. To conclude, the measurements are satisfying. Iron oxide has an absorbance rate of nearly 97% and titanium oxide with lower concentration has an absorbance of nearly 92%. Titanium oxide is a diamagnetic material and the reflection loss value increases as concentration decreases. So a good value can be obtained with less titanium oxide. With this, the radar absorbing material on the cover will weigh less. Fuel economy and flight time are one of the most important features of a plane. And as it weighs less, those will increase. These changes will create a big difference. Also, epoxy resin gives us a cheap molding material option. The coating for planes will cost significantly cheaper by the use of epoxy resin. At the end, what is the next step? The next step is to experiment these materials on larger surfaces to model an actual airplane. Thank you.